Hi everyone, welcome to a new video. So in this statistics series, in this video, we will just see what is central limit theorem, right? So this is one of the important topic in statistics. So we will just understand this central limit theorem in this video. So make sure to subscribe to the channel and also like this video, right? Central limit theorem. So what's this central limit theorem and what's the use of it? So first let's understand the definition, right? So the central limit theorem states that the distribution of sample means from a population will be approximately normal, right? Regardless of the distribution of this population, the distribution of the sample means will be approximately normal. So that's this statement of central limit theorem. We will just decode this statement and we will just understand what's this central limit theorem. So for example, let's take this is the population, right? So this is the population. Like let's take these are the people in a village, right? So like you just want to find the average height of the people in this village, right? So let's take that. Let's take this example, and the central limit theorem states that. So if you just take sample from this sample from this population, right? So this is the sample of the population. Sample. This is the sample from the population. And similarly, we will just take multiple samples, right? So I've just taken 3 samples from this population. So if you just find the mean of these samples, and if you just plot this in, a distribution, the distribution will be normal. So that's the central limit theorem. So we just have the population. If you just take samples from this distribution, like the population, samples from the population, and if you just take the average of these samples, right? If you just find the mean of these samples, and if you just plot those means, it just forms a normal distribution. That's the central limit theorem, right? So for example, let's take these means as x1 bar, x2 bar, x3 bar. So these are the 3 means of the 3 different samples which we just extracted from the population. And if you just plot these 3 means, the distribution will be normal. So that's the central limit theorem, right? It's very simple. You just have the population. If you just take multiple samples, and if you just calculate the mean of the samples, and if you just plot that in the form of any distribution, if you just plot the distribution, it will be a normal distribution, right? It will be approximately normal distribution. So that's this entire central limit theorem. Yeah, that's the overall central limit theorem. What's the use for us? Like if you just apply central limit theorem to any problem, what's the use? What's the advantage of that? We'll just discuss that. So before that, we just want to see what's the rule of thumb for this central limit theorem. Rule of thumb in the sense, what are the conditions you just want to keep in mind when you're just performing this analysis, when you just doing this, right? So the sample size should be 30 or greater than that, right? You can see from this population, we just taken the sample, right? In this sample, the sample size should be like minimum it should be 30, and it can be more than that, right? So for example, let's take we just have around 1,000 people in this, right? In this village, we just have 1,000 people, and in this sample, let's take from the rule of thumb of central limit theorem, it should be greater than or equal to 30, right? So it should be like 30 people, or it can be greater than 30. So similarly for this, right, for these samples as well. So that's the rule of thumb. It should be number of the sample size should be greater than or equal to 30. So that's the rule of thumb. And one of the important thing here is, if you just increase the number of samples, if you just increase the sample size, right, for each sample, if you just increase the sample size, like the number of people in this example, then your distribution is more likely to be normal, right? When compared to the 30, if you just take let's take 40 or 50 or 100, if you just sample size is 100, right? So then there will be more chance that your distribution will be normal. So that's the rule of thumb. And also here I just mentioned only 3 samples, right? So even if you just increase the number of samples, then the distribution is more likely to be normal, right? So that's the rule of thumb for this central limit theorem. So I hope you understood what is this central limit theorem and the rule of thumb, the things which you just want to keep in mind when you're just performing this central limit theorem, right? I hope you understood. Now let's see what's the advantage of this central limit theorem. Why we just want to prove this? Why just want to perform this, right? Let's understand that. Like, what's the reason for applying the central limit theorem is the first thing is you don't want to know about your population, right? Like whatever it may be your population, whether it can be normal, right? Whether your population can be normal, or let's say whether it can be a right skewed, or let's say it can be left skewed, right? Whatever it may be your population, central limit theorem doesn't care, right? It doesn't want to know what's your population what is the distribution of your population. So whatever it may be your population, it will just take the samples and it will just calculate the means, and if you just plot that, if we will approximately, we'll just get the normal distribution. Like no need of population distribution, right? So we don't want to know about the population distribution. So that's one of the advantage. And why we just want to use it, right? So for example, let's say you just have the data and you just perform central limit theorem, and you just found that the samples which we just plotted are normal, right? Are normal. You just found that your distribution is normal. Your sample, like when you just plotted the samples, the distribution is normal. Now the main advantage is you can able to apply all the tests which is applicable for the normal distribution. So if the data is normal, if the data is normal, we can able to perform some particular tests, right? For example, let's say t-test, chi-square, and this kind of tests we just have, right? So we can able to apply all these tests on our data. So that's one of the main advantage. So when you just found that your sample distribution are normal, you can able to apply all these functions, all these statistical tools provided by the normal distribution. That's all. That's the reason why we will just perform this central limit theorem. Those are the two reasons why we will just perform this central limit theorem, right? One advantage is, one main thing is you don't want to know about your population. Whatever may be your population, it doesn't care whether maybe your population is left skewed, right skewed, or maybe it can be uniform distribution, normal distribution, whatever may be the distribution, right? The central limit theorem doesn't depend on that. It doesn't depend on your data, right? And also you just understood, right? Like if you just prove that the central limit theorem is if like the samples are normal, you can able to apply all the statistical tools, all the tests which we just perform on the normal distribution, right? We can able to perform all those tests on your data. So those are the two main things you just want to remember. So that's all for this video, right? So this is about central limit theorem. I hope you understood this video. I hope this is clear. Like if you have any kind of doubts, make sure to comment down below, and also join the WhatsApp group which are just linked in the description, right? Just ask your doubts there as well. And also like this video if you feel this useful, like this video, and also subscribe to the channel. So yeah, that's all for this video. I will see you in the next video. Until then, take care and thanks for watching.